Great, so we're going to get started, everyone. Thanks so much for joining PAI and the partnership on Gray Area for this webinar. And especially, we're really thankful to Gray Area for hosting us. This is actually an event hosted by Gray Area on Patch, which is their new online initiative trying to make sense of the COVID era and bring really great programming to the community despite our online world. So Gray Area has been building Patch as a way for the creative community to continue to learn, create, and connect together. So these online events are a way for us to come together, but also more importantly, to support artists like Lia, who's on this call, and organizations throughout this time. So we're really hopeful that some of you can support if you can. All donations go directly to supporting Gray Area and their ongoing artist events, and we'll add a link, or one of my colleagues will add a link in the chat as we go through the presentation. And please do check out Bitrate, which is an upcoming series with Magenta from Google Research, which some of you may be interested in. The series includes a month of events on the creative integration of machine learning and music, starting August 7th. But I will hand things over to Lia to kick things off.
Next slide. Hey everybody, so I'm Lia Coleman. So today we are here today to talk about AI art. AI art is art that is made using machine learning and AI. And this can span a wide variety of mediums, including images, video, music, poetry, and performance. But today we'll be mostly focusing on image and video. But please keep in mind that there are a wide breadth of mediums out there. So yeah, I'll go into some examples of AI artwork that is out there. Next slide. Yeah, so this is the piece you saw in the waiting room just now. This is one of my works. It was trained on 14,000 frames of images from flowers blooming. This is a StyleGAN 2 model, and I think in general, I tend to like creating pieces of work that are videos. Next slide. Derek Schultz is, he's an AI artist and designer who I co-teach AI art classes with. He often makes artwork from vintage botanical illustrations. The piece on the left is from a model called StyleGAN 2, and the piece on the right is an example of style transfer. And during one of our past classes, Derek said something that I thought was really poetic about AI artwork. He said that where you come in as an AI artist is in constructing the data set and deciding what to include and what not to include. And in this way, you're sort of defining the vocabulary, the words, and the restricted set of language that your network can use. And then what happens in the training process is that your neural network will generate a beautiful poem, piece of work from the set of visual language that you yourself as the AI artist have defined for it to use in the beginning. Next slide. Esteban Salgado is an AI artist who always creates his own data sets. So for this piece of work, Esteban algorithmically generated thousands of abstract vector shapes in Adobe Illustrator, then trained a StyleGAN 2 model on them. And yeah, I really love his work. It's really meditative and beautiful. So Esteban started as a collage artist, and he says that AI art and collage are actually really, really similar. Because in a collage, you take pieces from other places and recombine them in novel ways to make a new piece. And likewise with AI art, you're taking thousands of images and feeding them into a neural network, which then rehashes and recombines features from each of them to create a new generative piece. So Esteban is interested in the idea of transformation and how existing concepts can be used to express a new idea. Next slide. Kishi Yuma is a Japanese AI artist who's also an AI researcher. He often works with video as a data set and is often like a source of inspiration for my own work. He often uses data sets of flowers and the human form, and I recently interviewed him, which is linked here in the slides. This particular piece, which he created, is an example of a model called Next Frame Prediction, which takes a video as an input and then the model tries to predict from one frame what the next frame will be. And then from that prediction of what the next frame is, it'll try and predict what the next frame will be. So naturally, over time, it just kind of gets like weirder and weirder as it drifts. And yeah, with that brief taster of AI art aside, let's tell you guys who we are. So I'm Lia. I make art with AI, and I also teach people how to do it. I've been working in machine learning for about 2.5 years. I first started out with training image and video models for detection of harmful content, and then dabbled a little bit in academic research, presenting at NeurIPS, the NeurIPS 2019 workshop on creativity. But today, I'm a full-time artist and educator teaching others how to use AI in their artwork.
Thanks so much, Lia. Hi, everyone. I'm Claire Leibowicz, and while I'm not an AI artist like Lia or Emily, I do spend my days for the past several years thinking about how we can actually use AI to create content, specifically images and videos, in a really responsible way. I lead AI and media integrity efforts at the Partnership on AI, which we'll describe in a few slides. And we mostly work with industry, so technology companies, media entities, those in civil society and academia around the world, to think about the responsible deployment of AI. I actually come to this work from a cognitive science research background, so I really care deeply about how people encounter, experience, and ultimately think about technology.
Hi, everyone. I'm Emily. I'm a research fellow at the Partnership on AI, studying labels for manipulated media. My background's in human-computer interaction and linguistics. Before PAI, I led UX for the News Provenance Project about misinformation and photojournalism at the New York Times R&D Lab. I'm also personally very interested in AI art and met Lia as a student in her Style GAN 2 class with Derek Saltz, which is excellent. I recommend you all.
Great. So a little bit more context about the Partnership on AI, which we'll refer to as PAI because it's a mouthful. PAI, as I said, is a nonprofit, multi-stakeholder global organization devoted to the responsible development and deployment of AI. And our origin story speaks volumes to kind of our DNA and who we are as an institution. So a little over 2.5 years ago, the heads of AI research at some of the largest technology companies, so Facebook, Apple, Amazon, DeepMind, Google, IBM, and Microsoft, came together and transcended their competitive interests to really work towards this goal of creating AI that benefits people and society. And really notably, they realize it's not just the tech industry that can do that alone. Some of these problems really require the participation of, again, as I said, civil society, media, other aspects of industry, and notably diverse voices from around the world. So over the past few years, we've cultivated an over 100 partner strong community of organizations. And it's really notable that the bulk of those organizations are nonprofit entities. Now, of course, creating responsible AI is quite a broad mandate. And one area that's really ripe for multi-stakeholder coordination and attention is that of AI and media integrity. So this question of how we ultimately ensure in the AI digital realm in which we live in the 21st century, that we have a healthy information ecosystem, that we can have high quality public discourse online. And ultimately, a lot of our time is given to how we prevent the bad stuff, how we ensure that mis and disinformation doesn't spread online. And we do this alongside many partners. Some really active participants are seen here, including some names you may know, the New York Times, Facebook, Witness, a human rights and video organization that has its own work in deepfake art, which I will plug here. And importantly, all of these equities are extremely important to trying to further the positive use cases and positive information potential, which we'll describe today, of AI moving forward. So we'd actually love to try and engage you and get a sense of what brings you here. It's kind of anonymous in webinar form. Some of you may be doing other things, but if you could just put in the chat and we'll try and take a look. What prompted you to join? What inspired you to come? Are you an AI artist? Are you not? It's okay if you're not. And what are you hoping to learn over the course of the hour? And I need to figure out how to see the chat button. Don't be shy. CS researchers. An AI art novice who's curious to learn more. Someone shouted out GPT-3, which is synthetic text. So this will mostly focus on images, but we totally pay attention to synthetic text too. NLP engineer, a flurry of activity that I'm trying to keep up with. AI art aficionado. Great, so we clearly have a flurry of experience. Some of you are AI veterans, others more novice. So we're gonna really try to capture kind of an intro to this realm and some practical tips if you're thinking about some of the responsible implications of AI. So over the course of the presentation, we'll start by just diving into the context for AI and manipulated media. We think it's really important when thinking about one use case, AI art in this instance, to actually situate some of the kind of responsible AI conundrums that may come up in art in the broader milieu of manipulated media today. We'll then pivot into actually examples of AI art, some tricky use cases where there have been some ethical challenges or questions that those use cases provoke. And then we'll offer some practical tips for making AI art responsibly. And of course, some time for Q&A. So to begin with, we know there are many, many definitions of AI that get debated to no end, but at a very simple level, we think of it as computer programs that can actually make sense of and access data and use that data to learn something for themselves. And we'll define manipulated media as any image or video with edited content or context. So not just the artifact that's edited, but also potentially the context around it. So of course, Lia's example of AI art is one form of manipulated media. But, and this is embarrassing, this is also a form of manipulated media. On the left, you are actually looking at my first Instagram post ever, which is heavily filtered, so you may not even be able to gauge what it is. And on the right is a ludicrous attempt by me to play around with Instagram and see what you can actually do today. And while these are, again, way less artistic than Lia's use case, they are, in fact, manipulated media. And while they're there to just poke fun or you know, maybe send to some of my friends, ultimately, we need to think about certain examples where there's actually kind of a benign impact from these media. Now, this strikes a bit of a different tenor. So what you're looking at here is another form of manipulated media, actually from the 1930s, so well before the dawn of the Instagram or AI era, in which Joseph Stalin, who's depicted in the middle of the image on the left and the rightward-most individual on the image on the right, has actually had the man next to him removed adjacent to the Moscow Canal. Now, clearly, people have been manipulating media for a long time using low-tech methods. And there are use cases like this one that can kind of be propagandistic or trying to disrupt the historical narrative that are quite different from the Instagram example I just showed you. But it's not actually even the image itself being edited that's the only way to manipulate media today. This caption reads, "Disgusting," in all caps lock, Black Lives Matter protesters decided to vandalize a veterans memorial for those who died in the Vietnam War. But if you were to click through this on Facebook, even though it was one of the top trending posts on the United States Facebook in the month of June for a few days, you'll notice that PolitiFact would say this image is actually, it is indeed the Vietnam War Memorial, but it's actually several years old, and the war memorial gets vandalized quite often. So miscontextualizing, merely smacking a different caption on an image can have a really profound effect on its manipulation and the ultimate message it's trying to distill. Now, when we hear about deepfakes or you hear about AI-generated media, those examples require a lot of expertise and technical resources. But the examples I just showed are ones that we call cheap fakes, or typically those are videos, but imagery that requires not a lot of expertise. You know, all I had to do was sign on to Instagram to to put myself in a coffee cup, and Stalin obviously didn't use any sophisticated technology to actually manipulate the image. So you'll notice that those examples, the technique, it doesn't indicate anything about the actual use of the image to kind of sow discord or sow a different narrative or poke fun. And it also is quite simple compared to some of the AI techniques we see today.
And together, we're just getting started.
Here's a video of Joe Biden that's a little trickier, and clearly videos, not just static images, can be manipulated and potentially more impactful because they stick in our memory even more readily. Here, Biden is lolling his tongue. It may seem ludicrous to you, but it's really important that this actually isn't a deepfake. There wasn't AI really used. It was actually created by a conservative meme maker who basically took an image of Joe Biden from recently and stitched it together with a parody GIF from a photo animation app to make Biden look like this. Now, it doesn't take a lot of skill to do this. Of course, this use case may seem silly, but Twitter actually thought it was indeed past the threshold of kind of impactful enough to be labeled as manipulated media. And it also shows the potential that when we have apps that make some of these manipulations much more accessible, while that may be good for people for artistic expression, depending on the intent of the creator, they may be trying to parody Joe Biden, or they may actually be trying to convince the electorate that he's unfit for office. But here is an actual example of a deepfake video, and I will let it explain for itself what it is showing when the sound is on.
Can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or...
There's a language warning just in case anyone is sensitive to that.
How about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia.
So this video, it's interesting to wonder if you hadn't heard the disclaimer and seen the men side by side, if you would have actually known it was a fake video or if it was Obama. So our colleagues actually at the University of Washington have put together this fun game to try and underscore the potential of hyper-realistic imagery to confuse us. And these use GANs, which Lia will describe in a few minutes, to generate fake faces. And this is called Which Face is Real, which is a game. So we're actually gonna play it for 2 minutes, don't worry. And we encourage you to guess the rules of the game. Which of these faces is real, which you probably posited from the name of the website. So in the chat, hoping that other answers don't influence you either way, if you could guess which of these faces is real, please put your answer right or left in the chat. Wow, we have some confident, okay. Is anyone bold enough to say the right? Good job, LLI. I will commend you for, okay, which one is it? So those who guessed that the left was real were right. They were correct. Anyone have actually visual cues that they used to be able to assess that, or have you seen this game before? The background, the eyes are weird, earlobes, so we have forensic experts on the call. Okay, we'll try one more to see if those, and if you didn't know, that's totally fine. I was new to this despite working in this realm. How about these two? Which is real, to remind people of the rules? Okay. Some divergent answers. Thank you for participating. The left is real, the right is fake. One more. Hair is weird, someone said. Didn't know hair being weird was a forensic way to... Wow, we do have some experts. Okay. Thank you to the contrarians in the audience for spicing this up. The right is real. So thanks for this game. Even if you're well versed in this, it's a good reminder that technology is getting good enough to, make it difficult to gauge which face is real viscerally, even if you weren't primed in a presentation to think that one of these faces is fake. You might not have known that they were. So again, these examples that we showed you, the Obama video, the imagery that we just kind of debated, make use of recent innovations in AI to make fake images. So Leah's going to walk us through a little bit how emergent technologies have actually helped us create really realistic imagery today.
Hey, so the tech that was used in many of these examples, especially the which face is real, is a type of deep neural network called a GAN. It's often used to generate really realistic images. And today I'll just describe how a GAN works, but you should also keep in mind that there are all these different other types of tech used, especially in other mediums such as music and text, which I've linked to here. Next slide. Yeah, so what is a GAN? Well, GAN stands for Generative Adversarial Network. It is called generative because it does generate new images. It's called adversarial, which I'll go into a little bit in the next slide. And it's a network because it is a deep neural network. Yeah, so within a GAN itself, there are actually two different networks that are competing, which is why it's called an adversarial network. So within a GAN itself, there is a generator network and a discriminator network. Next slide. So what will happen during the training process of a GAN is the generator network will propose new images. It will generate new images, which then the discriminator's job is to tell whether or not it's a real image or a fake image, just like we were doing a second ago. And in the case, in the process of training, the discriminator might reject some images and the generator will go back and edit and get better through time. So the typical analogy that people use for a GAN is that of a forger and a bank. In this case, the forger is the generator trying to make counterfeit bills, and the discriminator's job is to try and detect these fakes. So in the beginning of the training process, your generator will produce pretty low fidelity generations like this dollar bill. And then it'll take it to the discriminator and the discriminator will be like, that's not a real dollar bill. And then the generator will go back and edit and get slightly better. Next slide. Yeah. And then through the process of iterative training, the generator will be able to produce better and better prototypes as both the discriminator gets better at detecting fakes. Until you get to a point where to many people, it's just indistinguishable from a real dollar bill or a real human face. So how did GANs get so good at making realistic fakes? Well, GANs were first introduced in 2014 by Ian Goodfellow. Back then, the size of the images generated were really, really small and black and white. And then from 2014 all the way up to today, advances in GPU compute power and also different tricks when training, such as progressive growth. Today, about the state of the art in terms of GAN generations is 1024 by 1024 pixels, which are really high fidelity and for most people indistinguishable from real photos of real people. And as you can see here, GANs can be used to create hyper-realistic fake faces, but they can also be used in a variety of different contexts for different purposes. And Claire will talk more about these next.
So as you probably gleaned on that spectrum of technologies we can use to make manipulated media, and also the different examples I showed at the top to exemplify that, ultimately the technique used to make a piece of manipulated media doesn't actually say anything about how that media is used. So whether or not I use AI to make a piece of content doesn't say if I'm using that for artistic purposes or for nefarious purposes to game an election, for example. And it's really important to think about how we can use this technology. So one example here, and we're going to walk through several, keeping in mind that there's a slew of other examples we don't have time to touch upon. One that's really top of mind for PAI as an institution is mis and disinformation. You may typically hear this described as fake news, but we think describing the spectrum of mis and disinformation, which attends to the falseness of the content and context, and also the intent of the creator, which is a term borrowed from our peers at First Draft, which is a mis and disinformation nonprofit, is a much more illustrative use of terminology to describe this suite of examples. So this isn't a video, but it's an image representing an incident a little over a year ago in which a real video of Nancy Pelosi speaking was merely slowed down to imply that she was unfit for office or drunk or slurring her speech. And you might imagine that if that video appeared on The Onion, for example, which is a satirical news site, it wouldn't seem problematic. It was merely satirizing someone, which is a kind of benign use case and actually really powerful one in the world of public discourse. But in this instance, it went viral on Facebook and seemed to imply to a lot of political news outlets that Nancy Pelosi was unfit for office. So it seemed like there was an intention to incite this confusion. And it's really important to think about the different motivations in this very alliterative slide that people may have for creating manipulated media to misinform. It may be actually for propaganda, just as Stalin was doing years ago, or for political influence, but you also just may be doing poor journalism, parodying, which is really powerful, to provoke, and there are a whole slew of incentives that people may have that may change the character of the actual content. So of course, many of the platforms we work with, it's top of mind for them to think about how they can gauge what content is what. And I think as we haven't seen a ton of examples of mis and disinformation that are AI generated yet, but many platforms are trying to anticipate a reality where there's a lot of easily created AI content that's hard to detect with the naked eye. So just a few months ago, PAI oversaw some of the parameters of the Deepfake Detection Challenge, which was spawned by Facebook and some other technology companies to mobilize the AI research community to create models that can detect whether or not video imagery has been manipulated. And what's really important about that to note is that's merely a triage mechanism. It says nothing if it's manipulated for those different motivations on the previous slide. And ultimately, right now, we see a lot more research in the AI field on generating or creating synthetic content than actually detecting it and trying to gauge if something's been manipulated retroactively. So it's a really important issue area and preemptive part of a strategy for trying to find some of the synthetic content that may actually be trying to misinform or be created for nefarious purposes. But as I suggested on the earlier slide, we don't see a ton of AI-generated mis and disinformation today. And while it's something we're anticipating, the bulk of what we see now, our colleagues at Deeptrace reported in 2019 that the bulk of synthetic AI-based content is used in the context of non-consensual sexual exploitation or deepfake porn. So it's really important to ground, even though AI art may be 2% or 1% of what we see, a large swath of the content we see online or deepfake videos are used for pornographic purposes. But it's not all harmful, and really important use case that's positive in the spirit of trying to optimize AI's use for positive use cases is privacy protection. So just recently, actually, there's a documentary film on Chechnyan LGBTQ individuals who are speaking openly about the kind of stereotyping and persecution they've faced in the Russian Republic. And in order to do so, they were deepfaked in order to mask their identity, which is a really powerful use case for this technology. And of course, we have AI art, which not only can be beautiful, but can be used for advocacy, to satirize, to speak truth to power. And I think it's extremely important to obviously dwell somewhat on some of the negative or harmful use cases for the technology, but also to remember that the technology in and of itself is less important than actually what it's being used for. So Lia is going to dive into a lot of more detail on AI art in particular.
Yeah, so I'm going to talk a little bit about AI art and how you would go about making a piece of AI artwork. So again, as I said in the beginning, AI art is art that is made using machine learning or artificial intelligence. Next slide. And here's a brief refresher of all the pieces of AI art we saw earlier today. Next slide. And so how all of those pieces were made, I will describe to you in a little bit. Next slide. Yeah, so you will need a data set, model code, which is the actual GitHub repo you're using, and also training resources, which often cost money. These will be the GPUs that are actually training your model for you. And where do you find each of these? For your data set, you can either take your own photos or videos or scrape existing work from the internet. For what most people use, the StyleGAN2 model, you'll generally want about 1,000 or more images, which can take a little work to compile. You will, at minimum, need 500 images to produce a good result. Next. And as for the model code, often you'll be using GitHub repos from academic paper releases. A lot of the time it will be a paper from NVIDIA. A caveat for this is that you will need a little bit of coding experience. You won't need to code per se or write your own code, but you'll generally need to know how to use terminal and debug error messages and all of that stuff. And as for the training resources, here are a couple of common platforms that people use. Paperspace and Google Cloud Platform are cloud GPU servers, which you can rent out. Runway is a platform which gives you access to a lot of different models to use for inference, but also allows you to train your own StyleGAN2 model and GPT-2 model. Or you can use your own GPU if you're kind of a power user and know how to write CUDA code. But it turns out that that is not a complete recipe by any means. It's not that straightforward. There have been many recent cases where things get a little bit hairy. And so next we'll hear some recent case studies highlighting the complexities of making AI art from Emily.
Thanks, Lia. So now I'll walk you through 5 case studies and what they can teach us about making artworks with AI techniques. So first, when it comes to deepfakes and harm, the potential harm that's most obvious is this kind of photorealistic fake. Now, if you were to scroll through Twitter around February of this year, you might have discovered this new political candidate on the Rhode Island scene named Andrew Waltz, except it turned out Andrew was a creation of Riley Waltz, who's now a senior in high school, who had been thinking about these issues in his history class and was inspired to test Twitter and Ballopedia's partnership for verification process to a non-existent candidate. Next slide. Now, using some creative copy and a fake photo from this person does not exist, which we saw earlier, which uses StyleGAN2 trained on some Flickr faces. He got both Twitter and Ballotpedia approved within a month. They were both ultimately taken down, but only when he himself got spooked enough by this process to sort of whistleblow on himself to CNN. Waltz says, if I could do this with so little time and money, imagine what a highly skilled team of people looking to do actual damage could do. And indeed, it seems such fakes are already in the wild. Take Mark Hoffman, DC, an entrepreneur and politician in DC, who was spotted by Bellingcat researcher Eric Toller not too long ago. At first glance, seems pretty legit. Next. You can even see him give a press conference. Seems like a real up-and-comer to me, this Mark Hoffman. Next. Now, maybe you got so good at that game earlier that this was also an easy one for you, but in case you missed it, Mark Hoffman, DC, is in fact not a real person, is a person who does not exist. And Bellingcat's Eric Toller points out several current tells, including my favorite new phrase, which is that his ears are nightmare factories. And yeah, teeth bizarre / wrong, a whole bunch of good cues there. Next. So it may seem to you that that kind of example doesn't apply to the kind of hyper abstract AI outputs you're planning on making. But take a recent Slack post from Claudia Ung, a student in Derek Schultz and Lia's runway class. Claudia started to generate these sometimes surreal, sometimes hyper-realistic slugs from as few as 100 examples. Claudia says some of her slugs were realistic enough that marine biologists have joked, but also not really joked, about how this kind of thing could be used or misused for a clickbait article. So I don't bring up this example to fearmonger as much as to make it clear how easily outputs that aren't intended for harm might be misused for motives like profit or politics. Artists using these tools are really on the front lines of discovering these complexities. Next slide. And bad actors can even come in the form of fellow quote unquote artists, exploiting the labor that you put into your data sets and models, as in the case of Robbie Barat and a French artist collective called Obvious. Robbie Barat was a teenager as well, actually, when he made and open sourced a model that generated fakes that looked like these kinds of oil paintings. In 2018, the French artist collective Obvious used this neural network and sold one of these outputs for over $400,000. Meanwhile, Barrett didn't get a cent of that money and was understandably pretty pissed, as you can see in this tweet here. This really raises the question of who owns AI art. You could say it's NVIDIA, the company that created the GAN architecture in the first place, that Robbie Barat then used to create an open source model. Is it obvious that then used that model to select and sell the output? So there are a lot of open questions about legally what that means around ownership and copyright. But what we really want to stress today is that that doesn't let you off the hook as humans who need to make AI art with care. And there are many personal steps you can take to understand AI systems, protect each other's privacy and livelihoods, gain consent, and reduce potential harms of misuse. Another case that really tests these issues arose this year when a Seattle-based programmer named Arfa created This Person Does Not Exist, obviously inspired by This Person Does Not Exist. So they used StyleGAN2 to train a furry persona generating model on more than 55,000 images pulled without permission from a furry art forum. Shown here are a few sample furry personas generated by that model. Next slide. But what exactly went into that data set? Whose identities and labor were represented in that forum? Next. So after This Person Does Not Exist was released, the furry fandom kind of rose up online. This is a close-knit community of independent creators who relies on independent commissions. And so they really saw this project as a threat to their livelihood, accusing ARFA of disrespect, asking for the choice to opt out, or complaining that they weren't even asked their permission in the first place to be included in this. And within days, actually, some of the outputs seemed so similar to the original furry artwork that the site was slapped with a DMCA copyright infringement complaint that was ultimately dropped. But it did raise these questions of what happens if the model happens to produce a copy of another artwork due to something called overfitting to a data set, or what if it just creates a near copy due to coincidental visual similarities, even if never trained on exact copies. Next slide. What ARFA concluded from this process is that ultimately it's up to the programmer or artists to ensure that the training data is broad enough that that doesn't happen. And I think you can decide for yourself whether ARPA was successful in that, looking at this example of an AI generated work on the left and an original artwork on the right. So what if ARPA had tried to ask the creators beforehand, like they were asking about? ARPA claims it would have been impossible to actually contact everyone involved, that there were more than about 10,000 different artist creators, many of which go by different names or may have left the fandom entirely. But is it impossible to get consent or give credit to those in your data set? For comparison, take a project by artist Everest Pipkin, I've Never Picked a Protected Flower. In this work, the poems included in the book use titles scraped from forum posts of users of wordreference.com, an ESL forum for translating phrases and idioms. While not AI generated, Everest's scraping technique is similar to the dataset creation process used for training models. Next. And what Everest did was actually credited all the names of those forum users in the back of the book, acknowledging the profound way that this work really depended on those forum users' work. And Everest has spoken a lot about this recently, and in a recent talk, they said to work with generative systems is to be a curator. To curate a corpus is to value the contributions inside of it. They're still artworks individually, and the people who make them are still artists. So curating your own corpora is to be able to deal with the original creators of your corpora as humans and as collaborators, not as data points. And that's, I think, a profoundly, deeply humanistic view that you should bring to all AI work that you create. And for our last case study, here's an artist who, here's an artist who I think really exemplifies this, Stephanie Dinkins. Her work and projects like Not the Only One on the left and Conversations with Bina 48 on the right really ask this question of how does an algorithm know what it knows, and interrogate the kind of flawed logics of this superhuman AI. And instead, she builds generative systems from small community-focused data, especially with communities of color. In Not the Only One, the project shown on the left, Dinkins is creating a multi-generational memoir of Black American families as told by a custom voice interactive AI trained on oral histories. And so she's been collecting these oral histories from 3 generations of women, and through this process is able to kind of represent these voices that are so often neglected in tech. And she even creates her own recipe for how to create an AI, but looks pretty different from what you might find if you're just looking around on GitHub. So she includes steps in her process of, for example, test deep braiding neural network using Toni Morrison Sula as data, several rounds of interviewing source subjects as this process of creating data, focusing on making the algorithmic output make sense, developing more incisive questions, and recruiting people of color as programmers and technologists to join the team. And so with those examples in mind, let's turn to what we can learn from them about making AI art responsibly. So this is PAI's definition of responsible AI. We want to make sure that the practice of developing and ensuring AI technologies are ethical, transparent, and inclusive for the benefit of people in society. And to start in that process, artists should ask themselves, what are the unintended harms that might be caused by releasing or not releasing your data set, model, code, and outputs? Just because you only intend to create art for an artist community doesn't mean others can't find and reappropriate your work. Threat modeling is the practice of identifying and prioritizing potential threats. When it comes to your AI project, it's worth mapping out who might attack your project, why, and how, as shown in this diagram from AI security firm Calypso AI. For example, imagine you're using a data set with potentially sensitive materials like protest photos. Say you want to make a vision of a protest that does not exist. This might sound like a cool project in theory, but think about who else might use that data and model and how. Are there state-sponsored actors or other parties that might take those fakes to spread disinformation? How would they do this? And how might you prevent that, for example, through stronger privacy and access controls or through deletion of the original data set? Next. Though note that if you're dealing with really technically sophisticated, organized actors, even the private features of your machine learning models may be recovered, as shown in this Microsoft security documentation about techniques for reconstructing private training data. What that means is if you're creating art from potentially sensitive data, take care to really do your research and talk to security experts to understand what you can do to keep those represented in the data set safe, as well as protect your own work from unintended uses. Next, beyond the harm of your outputs, it's important to think about the origin and effects of the systems you're depending on in the first place to make your work. So machine learning, you may not think about it, but it has a pretty significant carbon footprint. Emma Struble, a PhD candidate at University of Massachusetts Amherst, found that the transformer architecture actually can emit as much carbon as 5 cars in their lifetimes, especially using certain inefficiencies like neural network search. In practice, it's actually probably more than that, as other researchers continue to train from scratch with many rounds of fine-tuning for publishable results. Now, as an individual artist or maker with a certain tolerance for glitch, you likely won't run into quite those astronomical figures of those commercial and academic models, if only because using that much energy is literally very expensive and requires resources just to keep the GPUs cool, as some of the most hardcore AI artists are finding right now who train their own GPUs around the clock. Still, as a practice to check yourself, there are tools like the machine learning emissions calculator that came out of a NeurIPS paper in 2019 that you can use to check exactly what your emissions are. And be mindful of when you might be doing duplicative or otherwise wasteful training. Next, many systems that you might use in your AI project depend on data sets that have been annotated by people, often low-paid workers on platforms like Mechanical Turk. For example, ImageNet is a large visual database designed for use in visual object recognition software research, where some labels that are embedded in that include things like labeling Obama an anti-Semite, these random white bros, good people, and this guy in the middle who knows what's going on with him as accused. Understanding what data you're sourcing is really important to understanding the bias that might be in that. Is that labeling sort of necessarily is deeply subjective and often political. And one sort of flashpoint moment that really, if you're just getting started in this debate, this is really a good place to dive in to see where the thinking is. So recently a tweet from Denis Malamonov, a self-described art hooligan and creator of a machine learning and art community, released this collab notebook with a demo of this work from a paper where you could take a pixelated photo and get a deep fake from it. So a student on that thread replied, showing that the demo actually appeared to be biased in the favor of outputting images of white people due to what is in the data set. That post then sparked a pretty intense debate between Jan LeCun, VP and Chief AI Scientist at Facebook, and Timnit Gebru, a technical co-lead of the ethical AI team at Google, about how data can be a source of bias in machine learning systems, but isn't the only source. It's also about how the systems that generate these things in the first place and the the harms that can result from that. And so taking all of this together, what I really want to ask you all to do is consider, what are all of the things that went into the work that you're making? So next. So when explaining models and outputs, it's important to describe what these known biases and impacts are. At a recent Partnership on AI workshop about machine learning explainability, some of the common elements for describing these include context, which is the scenario in which the model is deployed, stakeholders, or those affected by the model or have a vested interest in it, interaction, which is the goal of the model and its explanation, and finally some kind of summary, which is like a human readable explanation of what into that. So one example of this in the data statement format from Emily Bender and Batya Friedman, you can see in this Twitter hate speech model where it describes exactly what labels were applied for what kind of content, these English tweets, in what locations, who provided those labels, which includes both experts and crowd workers, and then links to a longer description. Other projects like about ML at Partnership on AI are working to work with various stakeholders and diverse communities to come up with recommendations for increasing transparency and accountability with machine learning system documentation. So you can check out this draft now and even add in your own feedback. And you can also find on About ML a few good examples of systems that are trying to do this if you need inspiration for yourself. So for example, Google model cards offer a helpful format as well as OpenAI's GPT-2. And so now we're gonna go back to that recipe, and Leah's gonna tell you about how to do it responsibly.
Yeah, so let's get back to our how it's made recipe from earlier, but yeah, like Emily said, how to do it responsibly. But wait, before we even get back to that recipe, we have to think, why do we want to make AI artwork? You should first ask yourself, what are your objectives for using AI in your art? Are you looking for money? Are you looking for fame, notoriety? Do you want people to think you're smart? And this sort of brings us to the question of the can it be done mindset versus what are the implications if I can. I think a lot of problematic work in the past came as a result of the can it be done attitude of thinking, this is an interesting problem. I wonder what happens if I'm able to do this, rather than thinking, what are the implications if I actually can do it? Who will this affect? There is also a really great piece called The Creative Savior Complex, which can really help you think critically about the intentions and motivations for why you're making the art that you're making. Next slide. Yeah, so getting back to that recipe from earlier, you'll need a data set, model code, your training resources or GPU, and lastly, a plan for where all of this will live after you're done training. So going into the specifics of questions you should ask yourself when you're compiling your data set first, are you using other people's artwork, photos, or video in your data set, like in the case that you're scraping images from the internet? You should think about what is your relationship to the content in your data set, and are you respecting each of these individual images as a work by an actual other artist? If these images are in the public domain or Creative Commons, that's generally a less risky thing to do than using someone else's work. Also, in the case of preventing overfitting, you should make sure that your training data is diverse enough so that your model is not just pretty much spitting out the training data that you trained it on, in which case it might potentially just produce a copy of someone else's work. And there are some techniques you can use, like projection, to test how much your model is overfitting. And also, lastly, how might you contact the creators for permission to use their work or have them be involved in your entire artwork creation process? Also, if you are using people in your data set, do they know whether they're in your data set or not? How might you ask for consent of them? How do you feel if you were in your data set or your brother was in your data set? For your data set storage, where you're actually storing it, you should think about what is the worst case scenario in which case your large data set became suddenly public, and how could this affect the original people involved in the data set? Like, for example, if your data includes the entire body of work of a particular artist, how might they be affected if suddenly all their work is downloadable in a zip file? Also, in terms of data storage, will you be storing your data set in perpetuity after training, or will you be deleting all the data after like 30 days or 60 days? And for the people involved, are there ways to inform them about how long their data will be stored? And lastly, are there ways your data set is reinforcing existing biases? This came out really in that pixelated Obama example, because that data set itself was not diverse and did not include enough representation from people of color. Second, when you're using model code from GitHub repos, you should think about what is your relationship to the creators of these tools. Often case, it'll be NVIDIA. And are you comfortable with that relationship? If you're using someone else's code, like an individual AI researcher or someone who has just created this GitHub repo and open sourced it, are you crediting them and are you thanking them? And as for your training resources, the GPUs that you're using to train your model, again, think about your relationship to the platforms that you're using. If you're using Google Cloud Platform, are you comfortable with that engagement with Google? And also, what are the environmental costs of training your model? Is it duplicative to train from scratch? There is a technique where you train off of a pre-trained model, which will greatly reduce the amount of time that your training will need to take, and reduce it from, by about like half a day to a day or so of training, and save those resources. And fourth, your publishing plan. After your outputs are created, are you planning to put them in a gallery or a show? Will you get paid for this? Will you get publicity from this? In the cases that that's happening, it's really, really more important to think about these questions critically. And a question of, should you be open sourcing and releasing all of your work? You should think, why? What are your intentions for doing this? Do you trust every single person who will have access to this data? And if you really do need to release it, is it possible to release to a closed community of a couple of individuals who you all trust, rather than just releasing it to the internet? How could your decision to release this data affect other people, not just yourself, like people who are in your data set or whose code you have used, and have you checked with them? And have you created a threat model and sort of thought critically about how your machine learning system might be attacked by someone else who has bad intentions, and how might they do that and why? And all in all, do the benefits of releasing your model code or data set outweigh the potential risks? As well as for the people that are involved in your model code and data set, how are you crediting them? For the outputs that are created by your model, like the actual images and video, are they accessible to people with varying levels of access using video description or alt text? And have you documented all of your work, your process, with explainable AI fields to be transparent about what work went into this project? I think that last bit is pretty important, not only for others to understand your process and be able to critique it, but also that process of writing it down will help you check in with yourself about what you did and potential points that you should investigate further. So that is it for the complete recipe. And just to reiterate, we intentionally phrased these as questions to ask yourself, because as of today, there are no 100% cut and dry rules for when it comes to this. This is a very, very new area. So this is a topic of ongoing discussion and consideration, and Emily will next present some best practices to follow when making AI artwork.
Yeah, thanks, Leah. So a few things that we can say now, as you've seen from a bunch of those examples, probably the least risky approach you can take is to go ahead and make your own data set. As we saw in the works of Stephanie Dinkins, recording oral histories, or Esteban Salgado, who makes his own vector art. If you are going to scrape work with care. So try to prioritize work that is in the public domain, or work where you can directly ask for permission from those whose identity or work is represented in that data set. And in general, credit the work of others whenever possible. So that means if you're posting online, tag the people who are involved and thank them. This goes for artists whose work is in your data set, as well as people who may have shared their code or model that you're using. And finally, as Leah was saying, using explainable AI fields, try to describe what you did in detail. So documenting your work will allow others and yourself to really learn from and critique your process and help people better access your work. Because this is such a new field, things are changing fast, and new use cases are popping up every day that kind of bring new ethical questions and challenges. So we really encourage you to keep engaging with thinkers in this field as things change, including people like Kate Crawford and Meredith Whitaker at AI Now, academics like Ruha Benjamin, Safiya Noble, who've done a lot of thinking in this space, and many more. This is not an exhaustive list, and you can visit this tiny URL to a doc that we created, which lists these resources and more at tiny.cc/responsibleAIart, and even leave your own comments if you think that there's something that we missed. Next.
Yeah, and to keep up, stay up to date with AI artwork. This is a non-exhaustive list of people that are working in this field, a list of artists and a list of coders. To be clear, like the line between the two is very blurred, and often people will span both. There's also Luba Elliott, who is a creator and organizes AI artwork events, and she has this creative AI newsletter, which is pretty good for staying up to date with the latest in the AI art world. And even though this presentation didn't focus on AI generated music, I've linked a couple starting points of people who are really great to start looking into that. Yeah. And yeah, so that brings us to the end of our presentation. Thank you all.
We want to give special thanks to Gray Area for making this possible and working with us at the Partnership on AI, as well as the broader PAI community, including the AI and Media Integrity Steering Committee, the Artificial Images community and Slack that Leah and Derek are part of was also really helpful and informative to a lot of this work, as well as SFPC, the School for Poetic Computation, that pointed us to a lot of resources that we directly included this. So thank you all. And now we have about 20 minutes, it looks like, for questions, and a lot of really thoughtful questions that I've already seen coming in. And so if you haven't asked a question yet, at the bottom of the screen, there's a little Q&A box where you can go in and type there. But I think to start off, all right.
Some people have posted, if you've posted a question in the chat, I've been trying to monitor them and attend to them, but we're gonna probably start with some of those that were posted in the Q&A section of the webinar.
Thank you. So Ben Bogart asks, is training data inherently extractive or exploitative? You want to take that one, Claire?
Yeah, that's a very good question, and it's hard that we can't engage with the audience. And Ben, thanks for the thoughtfulness. I think That is a philosophical question. And I think that some of the guardrails we've created here are in an attempt to, we're not going to answer that point blank, but to try and make it less so if you believe that it's inherently exploitative, so that you do it more responsibly, and try and create guardrails around that. But I think there is that question of, if you have any notion of a sample today, is it inherently extractive, if that's what you're getting at? But I think we are of the belief that aspirationally you can make it less so, and you can make it so that people are honored for their time or contributions, and also that we have documentation processes that make it so that it's not. So I think we don't think it is inherently, it may be by default, but we can create systems that make it so that it's not. And there are different ways to define that, right? So is it for the people who are in it, who are represented? Is it extractive? Is it extractive for the person who cultivated the original data set and then someone's using it? So I think at every layer of how you might define that, it's important to think about how to make it less so.
I would add, though, even if it's not inherently exploitative, I think it is inherently subjective. And so the curation frame, I think, is a really important one. And so even like diversified data set projects that like IBM and others are doing are still like making very subjective political choices in how they decide to quantify like what is a diverse data set. So I think that, yeah, there are steps you can take at that like large commercial model level, but as an artist, I think you in particular have a lot of control over, are you using your own photos and images with people who you know and get consent from? Are you using your own vector art? And I think that's a way to really ensure that you're not extracting someone else's work or doing cultural appropriation and gaining from that.
Maybe I'll pick the next question and throw it to someone. Someone asked, what makes great AI art besides novelty? Leah, do you want to take that?
Yeah, that's a really, I don't know, subjective question, I feel. I think, yeah, I mean, there's always the question of like, what makes a great work of art? I'm not going to try and answer that. But I feel like the high art world, or sort of like the gallery art world, is also like just beginning to see that AI art is a thing. And yeah, I think by ways of that, I think they still have a lot to, I don't know, become aware of and learn. Yeah, I think when making AI artwork, one thing that I personally like more than, or I personally have a preference for, is I think with AI generated work, sometimes people are like, let me create like a new Picasso, or what if Rembrandt like made another work? And I feel like that work is kind of, I don't know, not really creative at all. It's just sort of trying to reproduce someone else's body of work, which is especially problematic if it is still a person who is living. Like if you train your entire data set on like all the work of a particular artist, and you're like, what if the Beatles made another song? And that's actually something that Spotify is currently working on, where they're generating their own music. Yeah, so I do personally prefer AI artwork that where the artist creates their own data set, often goes out and collects their own work, or photographs, pictures of their own artwork. There's a ceramicist who she like painstakingly photographed each of her ceramic pieces and then put that through a StyleGAN 2 model. And then with the generated images, then picked a couple and then created new ceramic works based off of the inspiration from StyleGAN 2. And yeah, to cite that, I think it's a blog post called From Fran. And so, yeah, I like those kinds of works.
And quickly to add to that, here's a great line from Everest Pipkin again that I think answers this really beautifully, which is that I use AI in my own work, and I'm moderately positive about its capacity as a tool. But what I'm really excited about is not the capacity to launder knowledge into new mush, but to organize knowledge in ways that are transparent, traversable, and human readable. So I think that's a really nice framing of it too. And Alison Parrish is another artist who's written and spoken a lot about why in some ways you might get less interesting artistic outputs from using like big commercial models compared to kind of doing some of this more like personal curation kind of work with AI.
Yeah, and yeah, you made me think of Emily just now. Alison Parrish, she had this tweet, which I'm going to paraphrase right now, but she said like the most interesting question when it comes to AI art is not like, I don't know, can we make another Picasso, but what would Gertrude Stein have made with TensorFlow? And so I think as artists and as artists who have I don't know, the capacity for creativity, I think it's really important to think of these things as tools for your creativity and not to try and like recreate some existing piece of work.
There is one question about who is doing AI artwork using archives and historical content, and what particular issues have people grappled with in relation to these. Emily, did you want to chime in? I have an answer if it's not the same thing.
Nothing immediately jumps to mind except that is a really obvious case where I think doing a threat model of how like fake historical photos might be misused would be really important, because that is a lot of the kinds of like mis and disinformation you see going around, is like, you know, like Biden's grandpa was like the slave owner or whatever. Like, what if you generated that? But yeah, no immediate examples spring to mind for either of you.
This isn't yet historical context, but something we were toying with when we were putting together this presentation. The USC Shoah Foundation has been interviewing Holocaust survivors as holograms, because we're kind of in the last era in which Holocaust survivors will still be able to personally give talks. And so the idea is that we can deepfake them and have them respond in some way, in a more organic way. And I think we were talking about in the future, what if someone weaponized that for people to actually be you know, provoking Holocaust denial, as opposed to some of the survivors talking about their honest narrative. So while it's not yet archival, it's kind of like trying to preempt historical narrative, you know, dying out, and how might that be manipulated moving forward, almost in the attempt to preserve the unintended consequence of trying to preserve some of that history now. So that's not quite an answer to your question, but it's another way to grapple with historical narratives and some of this technology.
Maybe we can grab this other one of why limit the artist's role to training data, why not network structures and adjusting algorithms themselves? So I think that's a really important question, and one that we like sort of danced around a little bit, I think, by bringing up like the Jan LeCun and Timnit Gebru debate, which I think was really a debate around that exact question and like how to prioritize and emphasize that. And I think we should focus on network structures and adjusting algorithms. And as makers and artists, that's where I would point you again to work of those like Alison Parrish, who is part of the artistic process, kind of like inventing new algorithms and critiquing them.
Yeah, and to add on to that, like on the last slide, like there are a lot of AI artists who are also AI researchers who publish papers and actually like adjust the network structures themselves. And yeah, I think there's a lot of overlap between the two. I can also pluck off Ben's other question about under-overtraining. How does under-overtraining happen in GANs? 500 samples is a very small sample size for a deep network. Yeah, so I kind of like glossed over this a little bit, but for StyleGAN 2, when I was describing that you need like 500 minimum to 1,000 is like you're good. That's when you're training a StyleGAN model for art, you're generally training off of a pre-trained network. Often it will be the Flickr FFHQ faces data set. And yeah, because you're sort of doing something which is called transfer learning off of that pre-trained network, you only need about 500 to 1,000 images, and you don't need like an image data set that is as large as the Flickr data set, which I think is like 65,000 images.
But I also remember Derek and you saying in this class, like in that class, you can get really interesting outputs if your goals are like kind of artistic and abstract, even with less examples. Like it's still, I think there's room for experimentation there.
Yeah, there are a lot of AI artists too who are playing with like really, really small data sets. Helena Sarin comes to mind. And yeah, you can get away, depending on like what your creative output purpose is, with using smaller data sets too, if that's something you're aiming towards.
How does one make sure the data we are using for AI art is okay to use for commercial projects? Any guidelines? Yeah, I feel like this kind of gets into copyright territory for me, where the law, I mean, there's what you can legally do, which I think is different from like what is like responsible and ethical to do, because the law is probably like lagging in that respect. So yeah, do either of you have like immediate recommendations off the top of your heads?
I think a lot of the precedent is in just copyright infringement, but or just more like norm setting in the community, like we're trying to do here. So I can't point to a particularly good guideline.
Yeah, I think like the definitely like safe bet is to just check with the people whose data you're using and be like, hey, I'm using like this data in my artwork. Are you cool with it? Yeah, and often you'll find that a lot of artists are actually like excited that like someone is like interested in their work. Yeah, but generally check with people, and if you're posting online, like tag them and be like, hey, this is an output from a model I trained off of this person's stuff, this person's work.
Right, and you could also like as a commercial project or a company say like, I'm only going to use AI art that's like met these standards and, you know, like been described using some of these various frameworks. Just riffing.
We can just go in order. What are some good ideas for using GPT-3 for art purposes? And we clearly focused on imagery and video today, but we were actually just talking about complex artifacts or ones that use text and image. I mean, Lia, do you know any good examples of poetic?
In the way of like text, I would point you to Alison Parrish. I think she's teaching a class this summer on text-generated work. Yeah, her entire focus is like text and poetry and sounds and language. And also GPT-3 is kind of blowing up right now. So there are a lot of examples.
And for those who don't know, just because jargon is something we try and demystify, GPT-3 is a very large language model that OpenAI, an organization headquartered in the Bay Area, has put together that can generate synthetic text. So apologies if people know that, but for those who don't, totally fine.
Yeah, also I'd add to that list Robin Sloan, who actually we didn't talk about, but probably should have, who's done a lot of really, really interesting work with AI generated text. And I think a lot of the experimentation and opportunities there are actually probably in like explainability and interfaces. So Robin Sloan's done some really interesting work with like gradients of text predictions, where you can kind of like get more of a sense of like the latent space that predictions are being made from. So it's less like here's like a scary good output out of context of nowhere versus like, you know, maybe a gradient of meanings given the same kind of like priming text from different like points in the model or something like that. So Robin Sloan, yeah, I'll add that to the research stuff.
Flurry of questions now. We'll go in order. We have a question that says Clearview AI, which is a facial recognition startup, scraped the web for faces without permission to create their facial recognition software. And this wasn't determined to be illegal. How is this possible? triple question mark. I never would have given permission. It feels so unethical. I think this connects to the copyright question and Emily's elegant observation that the law lags behind some of people's technical savviness. But I don't know a bit more context about the Clearview AI legal battle, but I do know that they toyed the line with community guidelines on certain large platforms to try and scrape content.
Yeah, and if you're an artist interested in this stuff, I think those are exactly like the kind of debates you should be paying attention to, and like the legislation around that, and like what you think is responsible and makes sense and contribute to that if you're learning about these things. Next one, I'd love to hear the panelists talk more about how they think about code/data as original creative products or as open source tools. This bears on the ethical commitments noted, the PAI responsibility slides, and also on financial support for artists. For instance, in the Bellamy example, Barak called his original outputs tools, which in part allowed Obvious to appropriate it for their own work and exclusive profit. Yeah, no, this is a really good question. And I think like this is also related to the kind of like lack of public understanding on like what exactly AI generated like artwork versus like tools versus outputs, what that even is. And I remember one of Barrett's complaints like in the article about that is that Obvious was framing his work as like this magical AI product in a way that like really got under his skin, where he had to explain each time like, no, that's not how it works. So yeah, I mean, I think original creative products versus open source tools, I mean, it seems pretty clear to me like on the ends of the spectrum that like NVIDIA is making tools, and like someone like Alison Parrish is making creative products, even if they're like dealing with algorithms. But I'm curious if either of you have anything to add to that. I think there's like not a super clear way to define that. I will take that silence as nothing to add, but I would love for someone to write that blog post. Maybe it will be us. Okay, we've only got 2 more minutes here and a few more questions to get through.
Maybe we can take one more question in the interest of time.
We have a question from Suash. How do you deal with AI taking away jobs when art will be created by AI? You feel good, excited, or bad, guilty about it? So about this question, I don't think AI is going to replace artists anytime soon. Just because I think sort of when you're working with AI, you kind of realize how unintelligent it is and how incapable of like new creative expression it is capable of. I think like ultimately it still requires a lot of painstaking curation. Often you'll have a model that just like spits out a lot of stuff, and then it's up to the artists themselves to decide to pick from, I don't know, thousands of generations, which ones to keep and which ones create the message. Like without, I feel, the artist's vision or like the human hand, I don't think that the AI art would, or that the network itself would be able to produce really great artwork. I view it kind of like as a tool for expression of the artist themselves.
And that seems like a nice note to end on. Thanks so much to everyone for joining. I think we had our emails in the slide, and it might be in the link that Emily provided, which we can drop in the chat. But thanks so much for being active participants across the spectrum of Q&A to silly games embedded within the presentation. And we look forward to hopefully keeping in touch with some of you. And thank you again to Gray Area. Please keep your eyes out for some of their programming in the future. Thanks, everyone.
Thank you.